Hi guys, we're going to try this. Now, first things first, I will be posting a separate set of notes for you to look at, just in case you can't read my handwriting because it's awful. So, we're talking about ionic bonding, and if you look at the side objectives, we're looking at stable electron configurations, chemical properties using valence electrons. That's talking about reactive or not. Describe how an ionic bond forms and how ionization energy affects the process. Predict the composition of an ionic compound from its formula. Relate the properties of ionic compounds to the structure of crystal lattices. So we start by talking about stable electron configurations. And actually, this is supposed to say stable atoms. Okay? So stable atoms have 8 valence electrons, right? We've talked about that. We talked about how, group 1 has 1, group 2 has 2. We get all the way to group 18, which we labeled as the noble gases. And so 18 minus 10 is 8, and so there is 8 valence electrons. Which means if they have 8 valence electrons, they have a stable electron configuration. Yesterday at the start of class, we started learning about electron dot diagrams, and we start that way just so we can recognize how to first draw basically the first step of our bonds. The diagram is the first step for this. So an electron dot diagram is essentially just a diagram showing valence electrons. Okay, so it's just a diagram used to show valence electrons. Valence electrons are important because we need to know what it's going to do, right? They control all of the properties, like all of those reactive, how they're going to react. When we say how they're going to react, it means essentially how they're going to interact with another substance. Okay, so something with 8 valence electrons doesn't interact with other substance. They are unreactive, right? Okay. For electron dot diagrams, the symbol, so remember we put the symbol in the center, that represents the nucleus, and we know that in the nucleus it's the protons and the neutrons, right? And all inner electrons. Okay, the dots represent all valence electrons, and we know that valence electrons are just the electrons in the outermost shell, right? So we have inner valence electrons in the symbol and the dots that represent the valence electrons. And so I talked about how those diagrams are kind of the first step. And so once we draw what the 2 atoms look like, we kind of put them together and look at what happens. And so some atoms achieve stable electron configurations, which we've talked about, is just having 8 valence electrons. It doesn't really matter how many are inside the valence electrons, just 8 on the outside means it's stable. To do that, if they, for example, like sodium and chlorine, who neither of them have 8, they can get to 8 or kind of go backwards to 8 by transferring. Electrons with other atoms, forming ions. Okay, so when they transfer electrons, they form ions, and that's how we get bonds, because ions are atoms with charges. Hold on. Okay, so here's our example. Now it's a similar example in the book, and I'm going to kind of go step by step through the process of kind of how you figure this out. So we'll start with their dot diagrams right up here. Sodium is in group 1, so we know it has 1 valence electron, so it has 1 dot. Chlorine is in group 17, so 17 minus 10, it has 7 valence electrons, and it has 2 dots. We talked about in the last chapter how group 1 and group 17 are the most reactive groups. They're found in compounds. Well, these are the compounds that they could be found in. So what happens is this sodium atom, now it's an atom right now because it has no charge. It has the same number of protons and electrons. So we'll say it has 11 protons and 11 electrons, right? You could just get that from the atomic number on the periodic table. Okay, chlorine, actually I'm going to rewrite that so I have space. 11 protons, 11 electrons. Okay, chlorine we know has 17 protons and 17 electrons. Okay, well, what happens when we put sodium and chlorine together? Okay, so there's, oops, I'm going to redo that one. If I can find the undo button, maybe not. Okay, we'll just leave it. But we know that chlorine has 7, and so it's kind of like, okay, chlorine just needs 1 more to get to 8 because it has 7, right? 8 minus 7 is 1. And sodium would, essentially, it looks like it would need 7 more to get to 8, which would be would be a lot of work, a lot of energy required to get those 7. And so we can say that essentially they look like they're stable if they have 8 valence electrons or if they have none. Now, that's not that they have no valence electrons. It's more that they kind of go backwards. Like some of their inner electrons become valence now. And so that's kind of the idea. But so is it going to be easier for sodium to lose 1 or to gain 7? And it's easier to lose 1. Okay? So if we have a sodium ion, okay, it's lost its 1 valence electron, so its electron dot diagrams becomes the symbol, essentially with no dots, okay? And so it still has 11 protons because remember the number of protons never changes and they're positive, right? It now, because it's lost 1, so 11 electrons is how many it started with, minus 1 gives us 10 electrons, right? And electrons are negative, so 11 minus 10 gives us a positive 1 charge. Okay, and then we look at chlorine. Now chlorine has gained an electron, so now it has 8 dots. Okay, and if we look at 17 protons, positive, and 18 electrons, which are negative, we would get 17 minus 18 to give us a minus 1 charge. Okay, so we have a plus 1. This is now an ion. And so is this. Okay, we have a plus 1 and a minus 1. And if we think about magnets, okay, when you put 2 magnets together, they have opposite charges they attract. When you put 2 ions together, I'm sorry, I'm at my parents'. If you can hear a dog, that's what it is. But when you put 2 oppositely charged ions together, they are attracted to each other, and so they kind of stick together like magnets. And so we would form a compound of NaCl. You can see that it would be 1 Na and 1 Cl. And if you look in my picture, I have 1 Na and 1 Cl. All right, so we start looking at something called a chemical bond because essentially that's what we just formed. Okay, so a chemical bond is essentially a bond holding atoms together. Okay, so that's a chemical bond. But then we have types of chemical bonds, and the first one we're looking at is an ionic bond. And so this is a bond holding cations. Okay, some people pronounce them cations. I pronounce them cations. And anions. Together. And now some of you are like, well, Whitner, what the heck is a cation and an anion? We don't know that yet. Well, it's simply just a type of ion. So we'll kind of talk about that in just a second. But it's an ionic bond that's holding cations and anions together. This bond is something that forms when electrons transfer from one atom to another. Okay, so cation, now I have a little trick for this, is the positive ion. Okay, and now my little trick is, what does a positive symbol look like? It looks like a plus sign. What letter in the alphabet does that look like? It looks like a T. So cation has a T. It must be positive. These are formed from metals. Okay, so here's a big thing. Metals that lose electrons. So essentially what I just said is all metals, if it's a metal, it will lose electrons. So the arrow will go away from it. Okay, and anions are negative ions. Just trying to save on the handwriting. Okay, so negative N anions. Okay, that's kind of your two clues. If cations are formed from metals that lose electrons, the opposite side would be formed from, oh, that's bad, nonmetals that gain electrons. Okay? Sorry, this handwriting is so bad. So nonmetals that gain electrons, metals that lose electrons. So if Na plus is positive, Na, again, we have a few clues. So Na is a metal. It lost an electron, and it's positive. So we have positive metal, lost electrons. So this must be the cation. Okay, and then we have anions, or chlorine, which has gained electrons. It's a nonmetal, and it's negative. So this must be our anion. Okay. All right. So we're going to talk a little bit about ionization energy. So ionization energy, and I kind of didn't leave a lot of room, but ionization energy is the energy, and I abbreviate, energy required to remove electrons. Okay, and so if ionization energy is the energy required to remove electrons, that means that things that lose electrons are going to have low energy required to remove them. Things that gain electrons would have a high energy required to remove them. So which side of the table loses? The metals are over here, right? And we kind of follow this line. And then we have the nonmetals. I might have covered some metallites, but you get the picture. So where are we going to have our lower ionization energy? In the metals. Lose easily. Okay, and then where are we going to have higher ionization energy? In the nonmetals. Okay, what that's essentially saying, a high ionization energy, is just saying that it would require a lot of energy to remove electrons if we kind of just take out the words ionization energy and replace it with its definition. Higher energy required to remove an electron. Lower energy required to remove an electron. Things that lose electrons would have low ionization energy, low energy required. Things that typically gain electrons would have high energy required to remove their electrons because they want the electrons. They steal the electrons. Okay? All right, so we have our chemical formula. We're almost done here. Chemical formula is just a notation. Oops, maybe I should turn the pen on. Notation showing atoms in a compound. Okay, so it's just this notation that tells us the number of atoms in a compound. So before we talk about cross and drop method, I'm going to go through the atom electron dot diagram, show the transfer, do the ion electron dot diagram, and write the formula. Now, exactly what I do in this step, okay, is exactly what you need to do on the bottom half of your worksheet. Okay, so we'll start with calcium. Calcium is in group 2. It has 2 valence electrons. And then we use fluorine. Fluorine is in group 17. It has 7 valence electrons. Okay, and so we would first go, okay, metal, lose electrons, let's take one. Transfer one at a time, right? Well, now fluorine has 8, but chlorine still has 1 left. Like, it hasn't lost all of them. So we have to figure out, how the heck can I get rid of another one? Okay, calcium needs to lose another ion to be stable. So how do we do that? Well, the way we would do that is by having another fluorine. Okay, so we just have another fluorine. Now, you could do that the opposite way, where you have, you don't have enough electrons to fill the spaces provided. You could add more metals, right? And so we show that, so then that makes calcium a 2+. Why is that a 2+? Because it lost 2 electrons. Okay, so the positive charge comes from either how many electrons it lost or gained. And since electrons are negatively charged, when we lose electrons, we lose negative charge, so we get more positive, right? And then each fluorine would have 8 dots and a -1 charge. Now, some of you maybe are wondering, okay, but each fluorine gained 1, and so it's a total of 2. So wouldn't, oh, that's not good. So wouldn't fluorine have, I'm just going to do that. So wouldn't fluorine have a total of a -2 charge? Right? Well, you have 2 fluorines, and each one would have a -1 charge. So combined, it's a -2 charge. Now, one thing that we're going to talk about compounds in the next section is that they always have to be neutral, which means their charges always have to balance. And so you can see that if I have a 2+, in order to balance that out or to get that charge to be 0, we would need a 2-. So if I write the chemical formula, CaF2. Now that little 2, okay, we talked about this in your PhET lab. Okay, little numbers after a substance mean the number of atoms or ions of that substance. So we can see I have 1 calcium ion drawn and 2 fluorine ions drawn. So we get a compound of CaF2. Now that's great. Doing the whole diagram, that's what you're expected to do on your worksheet. However, this would be really tedious if every time we wanted to figure out an ionic compound, we had to go through this whole process. Okay, and it would be annoying. So we have a simpler method called the cross and drop method, and it's essentially exactly what you do, cross and drop. Now, one thing that everybody gets confused with is what happens to the positive and negative signs. Essentially, it's just it's like a math trick. You know how when you can figure out multiples of 9 by putting that finger down, like 3 times 9. If you put your third finger down, you can see 3 to start and 7 at the end. That's 37. But it's like a math trick. Okay, so essentially we're kind of disappearing the charges in our trick. So we're going to cross and drop charge values. So not the sign, but just the values. So if I start with calcium, calcium's in group 2, so it has a 2+ charge. And then I look at fluorine, and fluorine's in group 1, so it has a -1 charge. I'm going to change the color so you can see this a little bit. But so I'm going to circle the 2, and I'm going to circle the 1. Okay, because that kind of tells me those are the values. I just want the value of 2, not the positive 2. And I just want the value of 1, not the positive 1. So if we cross it over and drop it down. Okay, same thing, cross it over and drop it down. So we would get something that looks like Ca1F2. Now, the one thing about ionic formulas is 1s are just really redundant and not necessary. So what you'll see is they don't write the 1s. So it becomes CaF2, which is the same thing we just had written. Okay, so let's try potassium and oxygen, if I can the right color. So potassium is in group 1. Okay, so K, group 1, it would have started with 1 valence electron, which would mean it would lose 1 valence electron. So K is a +1 charge. Okay, and oxygen has 6 valence electrons. It needs 2 more to get to 8, so it would have a -2 charge, right? 2 more to get to 8. And we'll look at that on the worksheet a little bit. But if I take their values, cross and drop, right? So take the 1, cross and drop. Take the 2, cross and drop. I would get K, 2, O. And what that actually means is 2K plus ions and 1O, 2 minus ions. Okay? So that's kind of the notes. Now I'm going to switch over to the worksheet so I can go through the first row on the table and then kind of highlight some spots on your worksheet. So hopefully you have this by now. If you don't, it'd be a good idea to pause the video and go get it from the sub. Sodium, so we'll start kind of with sodium. I know we've already talked about this one. It's from your worksheet, but it'll just kind of help make sense. So the first 3 columns on the table you should know how to do because essentially you did this on your worksheet yesterday. So the number of protons of sodium is 11. Okay, if the number of protons in the atom is 11, the number of electrons in the atom is 11, right? And sodium's in group 1, so it has 1 valence electron. And now we need to decide if it's going to gain or lose. Okay, it's going to gain if it has more than 4. So I'll write that gain equals greater than 4. It's going to lose when it's less than 4. Okay, I guess it should be when valence electrons are less than 4. And when valence electrons are greater than 4. Right, because the focus is on the valence electrons. Okay, so if it has 1, is that greater than 4 or less than 4? It's less than 4, so it's going to lose, but I'm also going to include how many it's going to lose. It only has 1 valence electron, so it can only lose 1. Now, every time you see the word lose, you know that losing electrons forms positive ions. Okay, so we should put a positive symbol in there, but I also have to include the value, so it lost 1, so that means a positive 1 charge. Now, we want to know how many electrons total would be left in the ion. So if I have 11 in the atom, I lose 1, that means there are 10 left in the ion. Okay, let's look at chlorine. Chlorine has 17 protons and 17 electrons. I just looked at the atomic number, and then the number of valence electrons is 7. Is 7 greater than 4 or less than 4? It's greater than 4, so it will gain. Okay, now this one's a little bit more difficult because we have to figure out, well, how many will it gain? Well, it's always trying to go to 8. So how many more does it need to get to 8? It needs 1. Okay, so anytime you see the word gain, you want to add a negative symbol, and then however many electrons it gained is the value. So gain 1, negative 1 charge, the ion. Okay, and so then if we look at the total number of electrons in the ion, we can go 17 electrons in the atom. Gain 1 would be 18 electrons in the ion. Okay, I'm going to just do magnesium so you could see one that's not +1 or -1, just so you have an idea. And then I'll talk about the bottom half. So magnesium, has 12 protons. Okay, it also has 12 electrons. Okay, so if it's in group 2, it should have 2 valence electrons. Remember group number for valence electrons. Okay, so is 2 greater than 4 or less than 4? It's less than 4. So that means it's going to lose, and it's just going to lose that many, so lose 2. Now again, I see the word lose, so I put a positive, and then the number 2 because it loses 2. Okay, so 12 lose 2 would give me 10. Okay, so that's kind of the top part of your worksheet. And then the bottom part, draw electron dot diagrams for the atoms. Okay, so the first step is right here, step 1, draw electron dot diagrams for the atoms. So that's just like what we did on the worksheet yesterday. So just going to draw electron dot diagrams for the atoms. And then I'm going to show the transfers. That's the arrow going from the metal to the non-metal. And then I'm going to show the electron dot diagrams for the ions. And so remember, positive ions don't have any dots, and negative ions have 8 dots, right? And then I'm going to write the correct formula for the following compounds. So potassium and fluorine. Now, the nice part is all of these atoms, you just filled information in on the table. So when you're looking for the charge of these as ions, you just have to look at the table above. Hopefully this helps. Also, just another side note, after you finish this, you're going to have to cut out your ion puzzles. Okay, you're going to pick a colored sheet that has all of these different squiggly lines, like straight lines and squiggly lines, and you'll see positive and negative charges and element names and things like that. What you're going to do is there's pieces that look like, this is going to be a terrible drawing, but pieces that look like this. It might look like this. They might have 3 slots. What you'll find are these are all positive ions. They might be +1 or +2. Okay, and there are ones that look like this. Okay, or just maybe 1. Okay, so these are negative ions. You're going to cut them all out individually, and then all your positive pieces you're going to give to a partner. And that partner is also going to give you all their positive pieces. Now, if you're unsure, let's just make sure you get all the pieces cut out, and then we will work together on it on Monday. You can work on the worksheet and the packet once you've cut all the pieces out. All right, see you Monday.